Which of these carbons does not have any hydrogens attached to it? Carbon number 1, number 2, number 3, or carbon number 4? Let's make sure we understand how to identify where the carbons are in this molecule. And every time we have an end or a bend, we have a carbon. So this molecule right here is going to have 5 carbons because it has 3 ends and 2 bends. The key to finding the number of hydrogens which belong to each carbon, and the rules of bonding tell us that carbon must have 4 total bonds, 4 sticks. However, it's clear that when we represent molecules in bond line form, it limits the bonds we explicitly see. For instance, we see one of this carbon's bonds, even though it has 4 bonds in total. So to figure out how many hydrogens belong to each carbon, we need to count how many of these 4 bonds are already accounted for with the carbon-carbon connections, i.e. the ones that we see, and subtract that from 4. For example, this carbon has 4 bonds like the others, but we only see one of them, so it's got to have 4 minus 1, 3 hydrogens that it's attached to. So this carbon has 3 hydrogens. So with all the hydrogens drawn in, it's clear that this carbon right here has no hydrogens. But the question is, what number does this correspond to? Is it carbon number 1, 2, 3, or 4? Well, in order to number our carbons, we must identify our parent chain, the longest connection of carbons. And to do that, we might want to put our molecule back into bond line form, yet still keep track of our carbon of interest, the one that has no hydrogens. We highlight the parent or main carbon chain, which is the longest consecutive string of carbons within the molecule, and we see here that there are 4 carbons that make up the chain. Then we will assign each of our main carbons a number, 1 through 4, and you can see that there's 2 different possibilities, 2 directionalities of numbering, 1, 2, 3, 4, 1, 2, 3, 4. Regardless, however, we can eliminate carbons 1 and 4 because no matter which order we decide on, our carbon of interest, the one with no hydrogens, is either going to have a 2 or 3 number. And it just so happens that we must order the chain right to left because each of our functional groups make 1, 2, 3 numbers, whereas if we ordered it the other way, we would have a 2, 3, 4, which would be larger numbers overall. So therefore, carbon number 2 is the one with no hydrogens.